Hey, how's it going, guys? So today I'm going to be building a quadcopter completely from scratch. We're going to be building our own hardware, programming our own software, and I'm going to show you every step of the process. So the basic premise behind the idea is to have an Android phone mounted on the quadcopter. This is going to be our brains, and because it's connected to the internet, it will effectively allow us to get infinite range on the drone. So first, let's talk about the parts. We're going to have 12 4-foot long fiberglass rods. These we're going to use to build the frame of the quadcopter. Then we're going to have four Park 450 1200 kilovolt brushless motors. Each one of these is going to have a 4-inch carbon fiber prop on it. Each motor is going to connect to a 30 amp electronic speed controller. Each electronic speed controller is going to connect to a 2.2 amp hour battery, and each ESC is also going to connect to a Maestro Mini servo controller. These will allow us to connect to our Android phone over micro USB. The Android phone will then connect to the laptop, which is going to have a Leap motion controller. This is basically just an IR camera that will allow us to track the position of our hands, which will control the drone. So let's get started. First, we're going to be building the arms of the quadcopter. This is going to be comprised of two 14-inch fiberglass cuts that I've already made. These are going to be placed perpendicular to each other to form an X. This will provide 4 mounting places for each of the 4 motors. Next, we're going to be building the center of the frame. This is going to be the part of the drone that holds the phone, the servo controllers, and the battery. It's also going to be where all 4 arms attach to. We're going to be taking 4 5-inch fiberglass cuts, and we're going to be using JB Weld to glue them together. Once everything is dried, I'm going to begin attaching the 4 arms to the center of the frame. During this step, it is very important to keep everything properly aligned, as this step is vital to keeping the drone properly balanced. Next, I'm going to solder each motor to each ESC. While doing this, I'm going to make sure to wire it in such a way that 2 of the motors will turn clockwise, while the other 2 are going to turn counterclockwise. This counter rotation will allow the drone to rotate along the yaw axis. Now I'm going to begin creating the top of the frame. I'm going to start by gluing 8 short pegs onto the bottom of the frame. These are going to be used as support to hold on the second story. While that's drying, I'm going to finish creating the top of the frame by adding 3 pieces to add rigidity to the piece that we made earlier. Now that these pieces have finished drying, I'm going to begin taking off the tape and I'm going to try and attach the top of the frame. However, many of these pegs have shifted as they were drying, so I'm going to take a moment here and adjust some of them to allow for proper alignment. Now that we've finished most of the construction, I'm going to begin inserting some of the electronic components. I'm going to start with the 4 ESCs, which I'm going to mount to the inside of the frame using 2-sided mounting tape. Next, I'm going to solder all of the red positive leads for the ESCs together. And I'm also going to solder the black negative leads together. Later on, these connections are going to be connected directly to the battery. Now I'm going to begin attaching the 4 motors to the frame. For lack of a better connecting mechanism, I'm going to simply be using a mixture of super glue to attach them in place initially and JB Weld to attach them in place permanently. Next, I'm going to insert the battery diagonally into the frame, and I'm going to attach it using double-sided mounting tape. Then I'm going to attach the Maestro Mini servo controller to the side of the frame and connect each of the ESC's servo connectors to the first 4 channels. Now I'm going to clean up some of the loose and extra wires by holding them in place with electrical tape and zip ties. Finally, I'm going to attach a prop to each of the brushless motors. Then I'm going to use a thin screwdriver to tighten each one. Next, I'm going to attach the battery to each of the ESCs. And lastly, I'm going to be using Velcro tape to attach the Android phone to the bottom of the frame. And here are some pictures showing off the final result. Alright, now that we've finished all of the hardware, I'm going to get started talking about the software.
Now, for all of those concepts that we talk about here, you'll be able to find its corresponding source code on my GitHub page. The link for that is in the description. Now first, we're going to go over some high-level design. We have three main components: our controller, the UDP server, and the Android app. The UDP server is placed in the middle to facilitate for sending data between the controller and the Android app. Now we're going to look a bit closer at the controller. So first, we have this Leap Listener component. This is going to use the Leap Motion libraries to grab data from our physical Leap Motion controller. This is then going to be grabbed from by the GUI. The GUI is then going to combine this with some keyboard input. This includes the 4 arrow keys for forward, backward, left or right, and the shift and control key for increasing or decreasing our altitude. The GUI is then going to send this information as a formatted string to the UDP server. The UDP server will then have to forward this on to the drone app. Now, looking a bit closer at the app, first we have our UDP server, which is going to send all of the data from the controller onto what I'm calling the process loop. The process loop is an asynchronous task that I've started from the main activity. The process loop is going to control all of the motors as well as take data from all of the sensors. So first we have our motor handlers. This is going to interface through USB to our Maestro Mini, which is going to control all 4 of our motors. On the other side of things, we have our sensor handlers. This is going to collect and process data from our 2 primary sensors, which is the accelerometer and the gyroscope. It's going to use this information to calculate new values for each of the motors to keep the vehicle stabilized in the air and in the right part of the sky. Next, we're going to look at one of the most important components of this app. This is the stabilization feedback loop. This is what's going to keep the drone balanced in the air, which will help to keep the drone on course and stable. So first, we're going to use our gyroscope to grab our x-axis and y-axis rotation. We're going to call this A1 and A2. Then we're going to reach out to our UDP server and ask what the desired labels are. These are our desired A1 and our desired A2. We're then going to compare these 2 values, and based off of how this comparison works out, we're going to adjust the speed of the motors by some delta value. This delta value is going to be a constant that we specify in the code. It's going to work out to be our rotational acceleration. Once we've compared all of these values, we're going to use the new computed motor values to set a target value for each of the 4 motors. Once this is finished, we're going to loop back to the beginning and start all over again. Alright, so that just about does it for this tutorial. Hopefully in the next couple of days I can get a video of it flying online. When I do, you can click on the annotation below to view it. You can find a list of all the parts that were used, a link to the source code, and much more in the description. I hope that you've learned a thing or two about UAVs in this video. If you have any questions at all, please feel free to let me know in the comments. Thank you very much for watching.